Hello, I'm with Emily Bash, and today we're gonna work on kata that Emily's worked on. This is called the Lift Kata.
Today we're going to work on a different kata which I've been putting together lately. It's called the Lift Kata, and it's in a way similar to the Gilded Rose in that I want you to try doing it with an approval testing approach. At least today we're going to try it with an approval testing approach.
Yeah, I've never done it, so for me it's a first. I tried to do these things in Premiere, so let's see how things work.
Yeah, so approval testing is often used for legacy situations like Gilded Rose, but here we'll be building up new code and seeing how it differs from a standard TDD approach, hopefully. So do you want to put the GitHub page up on the screen?
So now you can see the GitHub page. I cloned it here. This is from me, but if you want to go on Emily's page, you'll find it here.
So this Lift Kata, I've got a starting position for it. So usually when you do a kata for new code, you start from scratch in your editor. But I'm decided that it would be useful to have a starting position for the approval testing approach, because one of the first things you need to do is to write a printer. And that's code that people maybe aren't so familiar with creating these kind of printers. So I thought, well, I'll just put a starting position up with the basic lift entities and a way to print them. And then it's a good starting position for doing the approval testing approach. So I've translated it into C#, Java, and Python so far, and other languages are welcome if you want to send me a pull request. And so if you scroll down, there's a description of the exercise a little bit. So as it says here, you've got a printer and enough of the implementation of the production code to have something to print. And then there's a little picture here of what it looks like. So when you print out a lift system, it could look like this. This system has got 4 lifts, A, B, C, and D. There are 4 floors, 0, 1, 2, 3. And you can see that lift A is on the 3rd floor and B is on the 2nd floor. C is also on the 2nd floor, but it's got its doors open. That's why it looks a bit different. And on the 1st floor, there's a down arrow showing that somebody's standing on the 1st floor and has pressed the down arrow. And then you can see on floor 0 there, you've got lift D, and there's a couple of stars. So lift A is got a request for the floor 0. So somebody is standing in lift A and has pressed floor 0. And so I've chosen to actually mark that on floor 0 rather than next to A. For lift D, it's also got somebody who's pressed on floor 0. And since the lift is standing on floor 0, that request is presumably about to be fulfilled because D just needs to open the doors. And then that request will be fulfilled.
Okay.
So that's what we've got so far, basically. We've got enough code to print out the state of the lift system. And I've introduced the concept. Lifts have doors, they have a floor, they have requests. And the lift system as a whole can have several lifts and calls from particular floors. So that's what you've got to start with. So if you scroll down a little, it goes to the description of the actual exercise, what you're trying to build. And you basically want to build code that's going to simulate a lift system. And everyone's been on a lift. You know how they work, basically. But here you've got to code that to make sure that the lift moves to the right floor. So it just explains here, lifts move between floors. You've got some buttons inside the lift that passengers press. There are calls. People can stand on a different floor and call the lift. And the lift has doors, which can be open or closed. And then some parts that haven't been implemented yet. These lifts that in the starting code, they don't move. So that's the part you need to write, at least at first.
So where's that one? In the code, in the texture?
So I'm just saying there's a line that says in the repository that much is already implemented and the following features are not yet implemented.
All right, so this one.
Yeah. So this is the part that we need to think about. So we need to get lifts to fulfill requests and fulfill calls and make sure that it doesn't move with its doors open, things like that. So this is a real-time system, and in a real lift real-time system, you'd have kind of an event loop that would go around really fast. But just to keep things a bit simple, we'll have a tick method, and when you call it, the system will move to the next state. And I'm assuming that that tick is long enough for the lift to move to any other floor or to open its doors, basically.
Okay.
So that's what you've got. So, and then it goes on to explain, well, when you've got the basic lift features working with one lift, you should get some more lifts and make sure that the right one is going to the right floor. And then there's some more features that you can implement around monitoring what floor each lift's on and making a ding when you open the doors. And those things aren't shown in the printer at the moment, so we'll leave them for a bit.
Okay.
So that's a basic explanation of the exercise. Should we look at the code?
Yes, let's look at the code. I see 4 classes, and I think there were some tests as well, right? Yeah.
Yes. So do you want to just run the tests and check that they're all passing? See that we've got everything set up?
Yeah. Great.
Great. So you can see there are some tests there already, but they're all for the Lift printer. So they're not actually testing any functionality. There isn't any functionality, but we can have a little look. We've got a Lift system class that might be interesting to look at.
We have a Lift system class, yes.
Right. So this is the one that's got a list of all the floors that they're going to have in the system, all the lifts, and all the calls. People standing on floors who press buttons. So I've already made some design decisions that the call belongs to the lift system. But then if you look at the lift class, so the lift class owns it's got an ID. It knows what floor it's on. It's got some requests, and it knows whether its doors are open. And that's basically all the lift stuff. Then the other 2 classes we've got here is a call class. And the call is for a particular floor and going in a particular direction. Because when you're standing on a floor, there's usually 2 buttons for up and down. So that's the direction is just up or down if you look at direction.
Yeah, and then direction is just up, down, yeah.